Okay, we've got this 16-meter piece of wire that's going to be divided into two parts. One part's going to form a circle, the other an isosceles right triangle. So here's the wire, 16 centimeters. We're going to cut it into two parts. We'll let x be one part, and 16 minus x will then be the other part. And you have a choice whether to let x be the perimeter of the triangle or the circumference of the circle. So I could interchange these two descriptions here, and the calculations and equations would look different, but you'll end up with the same answer. So for this video, I choose to say that x is the perimeter of the triangle. So here's your right triangle, and we need to find a formula for the area of that triangle in terms of x. So if I let y equal the length of the legs in an isosceles right triangle, the legs are equal, and the hypotenuse is radical 2 times one of the legs. So the perimeter is equal to the sum of those sides, 2y plus y radical 2. And if I solve for y, the length of a leg in terms of x is x divided by 2 plus the square root of 2. So the area of the triangle, again, in terms of x, is 1/2 the base times the height. But the base and the height are equal, so it's just this y squared. So here is a formula for the area of the triangle in terms of x. As far as the circle goes, 16 minus x, bending that into a circle, so 16 minus x is the circumference. But the circumference of a circle is 2 pi r. If I solve that for r, I get 16 minus x over 2 pi. Why did I have to find r? So that I can find the area of the circle in terms of x. Remember, this is the radius of the circle. So pi times the radius squared, simplified, gives us this. So now we have a formula for the area of the triangle as a sub 1, the area of this in terms of 2. If we add those two areas together, we've got a function for the area depending on this piece of the wire right here. And if I find the first derivative and set it equal to 0, I'll have critical number. I'll leave that to you. Apply the power rule. There's the derivative. Board 2 will set it equal to 0. Right here. I end up with this complex fraction. So I multiply numerator and denominator of the big fraction by the LCD of all the little denominators. And there is the value of x. Now we don't know if that generates a maximum area or a minimum area. You can see it's about 10.39. So the maximum and minimum areas are going to occur at a of 0, a of 16, or a of the critical number, which the critical number looks like it's about 10.4. And it turns out that, let's see, this gives the minimum. And when the wire doesn't have a triangle at all, that means we will have x equal to 0. And so a of 0, it turns out, gives a max. I'm going to send a link to a Desmos graph that does this calculation in the opposite way, where x is the circumference of the circle and 16 minus x is the perimeter of the triangle. You can take a look at that and see what the answers look like. There you go. Hope that helped. If you have any questions, post a comment.